Well, I started opening my mail, and I thought, well, I might as well have a mailbag day. Everyone else does. Ordered some stuff from Adafruit. I thought it was interesting that, you know, that they have their own labeled boxes now. That's neat. Well, what did I get? So the things in the mailbag are going to be the surface mount board, which we'll see, and that was $3 for 6 of them, and then a pocket multimeter for $25. And kind of a Jimmy Spudger tool opening knife for about $8. Well, one of the things is I noticed they had this little IFixit Jimmy tool, this blade. I got into it real quick because I have these in a little kit of IFixit tools, and the plastic ones just weren't really doing it. I was always going after something metal, so I got this from Adafruit and thought, yeah, that'd be a really nice addition to my iFixit bag when I start tearing apart laptops and phones and whatnot. So that's done. And then I ordered some, this is interesting, I got some 8-pin surface mount to through-hole adapters. But what's interesting is, look at that, that's amazing. That's like, they stuck it in there, vacuum sealed with desiccant, and bubble wrap all in one. Whoosh, wham! That's that's some amazing packaging. I don't know if you can appreciate that like I do, but wow, that is some serious let's pack it. And that Adafruit is doing. They've really upped their game since I bought from them before. It's been a little while since I bought anything little from them. I was using their smart boards, but the smart boards just were not thrilling me because, well, they just wouldn't sell quantities of like 8 or so, like I'm getting here. I'm getting 6, and they make you buy like things you don't even need. I wanted 8 pins specifically, and Adafruit's being real clever with this dip conversion here, in that you can do 65. You can do SOIC 8 or even a really fine TSOP 8, and if you just so happen to have SOI 8, and bingo, flip it over and you have SOI 8s on the same board. So it's you can do either one. So prototyping just got a little easier with those, and that's clever. I really like it. But I was mostly amazed with the packaging, and then I just love meters. I really love meters, and for the longest time, my go-to pocket meter has been this from Radio Shack. It's a Micronta. I'm going to say Micronta. I have other Microntas from Radio Shack. My very, very, very first meter when I was still in college was this Micronta, which is a Radio Shack brand. At the time, still love this thing. Keep it really close to my heart. And I got this too. This was my travel pocket one. But the thing I always hated about this one is it had just a few things you needed, but you had to turn it to off. And oh my gosh, the cells in this thing are expensive. You know, it's got the button cells, and if you don't turn it to off, this thing's dead the very next time you go to use it. Oh, so annoying, but love to have a pocket meter, throw it in my vehicle, throw it in my travel bag. Just can't be without it. So this is something Adafruit's selling. Boy, does that say China. It almost screams China. I almost hear China off this thing. I can't read kanji or any other types, but who knows what it says. But it's a Victor. And what I liked about it is they said, hey, this is auto off. And so looks like there's a few different models. 9200, this is the 921. So that's good. I'll link to these and all the stuff in my mailbag, so if you need something like this. Another thing is AAAs, and I use AAAs. Like my wireless mic that I use, this usually clips to my belt. This is AAA, so I keep piles of AAAs around. I get about 6 hours on my wireless mic, and it goes directly to my Sony camera. And let's see what we get. Nothing else in there. We get a little manual. Is it any English at all? Well, there's numbers. I can read the numbers, but no. There's not a word of English. Well, it looks like they have different meters they got in there. Well, I guess I wouldn't read the manual anyway, would I? Oh, it looks like we have a little bit of quality assurance in there. Say hello to QA number 2. They passed it in 2015, September 15th. Okay. And yeah, that's it's. Where's my other meter run off to already? Oh, there it is. It's not much different in size. I'd have to say, boy, I'm not gonna sweat the size. Just a hair thicker. How is it internally? It's got some weird little button on the front. I don't even know how to open the silly thing. Oh my goodness. Oh wow. It opens up like one of those old HP calculators. Clever. Okay, it's Cat 2 rated, DC-AC 600 volts. Looks like we're going to have got no batteries in it though, so we better pop the batteries in. So this is supposed to be clever. It's supposed to like keep the probes. So rather than having the probes all wrapped around like I've always done, these little probes get locked in, and then this is supposed to close up, and then you get a hard case. Clever. And you gotta like that dial. Oh, it's a real nice firm dial too. Oh, sweet. Oh, that's sweet. And you can do auto ranging apparently, or ranging. I wonder, it should be auto ranging for everything as if you want to go manual ranging. Let's pop the batteries in it. We got warning down there, 600 volts for that. Auto power off. That's why I wanted it. And true RMS? You're kidding. Really? Okay. So we got a little screw. Oops, it's not captured though, so you better not lose it. Oh wow, it's interesting. You can see some buttons in there. There's a couple of press buttons right there. It's got a select and a hold. What? Why would it have select and hold written on the back there? So we got the batteries in it, so let's take a look. We have auto. It says APO, so it says auto. Let me get a pointer device here. So it's going to say auto power off and auto ranging. Millivolts is defaulted to. That is a really smart looking dial, I must say. There's AC. It says AC there, millivolts. Wow. The screen was a little dirty here. I've goofed it a little bit when I first pulled it open. I got a little something on it. When I went to clean it, it got a little smudged right away. Dedicated diode. Now, you got to like that in a handheld, easy, cheap meter. Because you get instant diode testing. Very handy. And instant continuity, another thing, very handy for doing especially hobby stuff. That is amazing. And a dedicated ohm. I mean, no fiddling around for ohms, continuity, or diode. I like it. And I wonder, well, it says nanofarad, so nanofarad on the capacitor. I mean, wow, why not? Now, duty cycle is a bit, frequency, so it's not going to be so terribly handy for the hobbyist and stuff, but no amp, there's no place, you don't change leads on these things, so there's no amp ranges or anything like that. There's always going to be a volt ohm and not no amps, but that's fine. I wonder if ranging will work. Right now it says nanofarad. Can I force a range on it? No, definitely single range in that. Maybe it's multiple ranging in here. It's it ran up to mega ohms. If I can get a good light on that. Hard to look in the camera. And if I click it, so now it went down to overload under ohms. So it does let me change, now it's into kilo ohms. So it is letting me move the decimal in ohms. Of course, that's just going to be continuity. I wonder if it'll let me move the in here. Yeah, it lets me move the decimal. And in here, yep, it lets me move the decimal. Well, that's clever. And we automatically go back into like it went out. It's still auto power off, but it's went out of auto. It's manually ranging right now. But if I just switch and come back, oh, see, that's sweet. Immediately when you switch it, it knows I'm going to go back to auto ranging, because if you start changing your dial, you want it to be auto ranging again. Even if you go back, you want it to be auto ranging. This is the switch for duty cycle then. So when I'm over here in duty cycle, I can switch between percent duty cycle and hertz. And there's two off positions. Interestingly enough, you can't close the case because there's a slice here. You can't close the case when this off is here, but you can, if they would have moved this over here, then you could have had this off on either side and still close the case. So neither here nor there, I don't care because it's an auto power off feature anyway. And let's take a look at the, see how I like these and how easy they are to get these in and out. Because, well, that's interesting. There's lots of printing right here. Oh, wow, I didn't even look. We thank you very much for your purchase. Personal pocket multimeter. Autoranging, auto power off. Gives you the volt ranges, 400 millivolts up to 600 volts. And AC is the same. Ohms, 400 ohms for the low. 40 mega ohms. Really? That's pretty damn impressive. 40 mega ohms. Frequency can go up to 10 megahertz. Really? In a handheld multimeter? Okay, well, fine, we'll test that. Duty cycle 0.1 to 99.9. That's impressive range. And it can go down to 4 nanofarads. Well, there's sometimes you got to get into the picofarads, but the decimals are there for picofarads. So we'll check to see if we can, how far down we can go to a picofarad. It'd be nice to see if this did be flipping amazing if this thing could actually do 22 picofarads, just because the decimal would be nice, just to know what you're looking at. Up to 200 microfarads. And diode test does a 1.5 volt diode test, and continuity test under 60 ohms it'll beep. You know, I'm thoroughly impressed. The plastic is real cheap, but you know, certainly not any cheaper than this, I don't think. Yeah, no. And this screen is goobered up too. So the screen's going to goober up quick on you though. Well, what a mailbag. This is an exciting mailbag. I didn't know it was going to turn into a complete product review, but okay. Well, the leads are really thin. Wow, those are super sharp. Those are really sharp. Let's compare them to these. Compare the sharpness difference. It's dull, almost round on my Macrona, and these are very sharp. Sharpest test leads I have on anything almost. I bet you the metal is pretty soft though. It won't last long. And the leads on these are much bigger. These are, you know, these are 32 American wire gauge. I don't know what these are. They're not even labeled, but they're a lot thinner. And these lasted, well, since I was in college, so you can imagine. So I'm not so sure these, but they could be replaceable because I saw where they soldered on the board inside. So if you wanted to, you could replace them. But the point is, they have to be able to go back inside, and that's the convoluted mess. For this to really be, was always okay because you had this little piece of Velcro here, and it always wrapped around and it always closed, and it was nice. But how? If I pulled that up and said I was gonna, well, I want to put my test leads away for the day, how's that gonna go down? Maybe not the funnest thing I have to do every day. No. And they fit in there. There's no doubt they fit in there, but okay, I got them in there and lined up, and then, well, you know, certainly not as fast. A bit more fiddly. Yeah. You got to lift on this though. You can't just flip it. It'll hinge. You got to lift the hinge because it kind of folds over like that and kind of stays out of the way, so you can use it like this, which is nice. But then when you want to do it, you got to make sure this hinge comes all the way around. Huh. Interesting. Well, let's do a couple of tests here. That wasn't so bad to get those out of there. They're a bit difficult to get out. But in my Apple Watch case, I put my voltage standard because, you know, why not use your Apple case for something? So let's pull out a voltage standard here. It's let's turn it on. How long's this thing been on? Okay, maybe I shouldn't keep it in my Apple Watch thing, unless I just managed to flip it on just now. Well, I guess we could test to see how the batteries are doing, huh? We have a multimeter. Let's see. DC volts comes on. Let's see. We'll go like this. Well, they must have just switched on because it's reading 9 volts right now. 9.3. Yeah, it must have just switched on when I popped it out. 9.3. Yeah, it must have just been when I flipped the case open. But this is my voltage standard, and these are like essentially high tolerance. You're supposed to kind of turn on and leave it for a while, but this is the Pentaref voltage standard for the poor man's lab. I think I did a review on these. I don't remember now. It's supposed to be 0.1 volt, 1.25, 3, 5, and 10. Okay. And we'll go, it's supposed to be 0.1 and it's 0.0999. So yeah, real close. We'll switch up to the next range. So now we should be 1.2501, 1.250. The next one should be 3.0 because this is calibrated. The guy who made it wrote right on there exactly what he spec'd them out as. There should be 3.0 exactly. Man, it's only one point off. That is impressive. 5 even. Spot on with 5. And 10 volts. Spot on with 10 volts. Wow. Well, okay, so as far as voltage standard is concerned, this thing is great. Let's pull this out. Okay, so we'll turn that on. There we go. And now this one was supposed to be voltages, and that's what this is for. The voltage is supposed to be 5 volts, spot on. 5.00. Wow. Now this does AC, and for AC it's supposed to be 4.999 volts AC. So we'll switch our DMM check to AC, switch this to AC, and we should get 4.9999. 4.97. So it's a little off on that one. Also on here we should get frequency. We can do all 9s. Well, no, there's a 4 at the end. 99.994 hertz. So let's go over to hertz and check that. 9.998, so just a tweak off. I wonder if I went to duty cycle on that, then that would probably be 50. No, yeah, 50% duty cycle. What's it supposed to be? Duty cycle is supposed to be 50. Okay, so let's go to 100 ohms, should be 9.95 ohms. I could rel out before I do the ohms, but it's all 0. There's nothing, yeah, there's nothing to rel out, so there's no point in there's no point in relling out the leads if the leads are already 0 as far as this deep as this thing can read. So we'll go ahead and measure the resistors without bothering with the rel factor. And it is 100.1, and it's supposed to be 99.95. So it's a little high, and it's also 2 counts out on that. 10.0, it's a little out on that one too. It can't even go as deep as it, so it's definitely a little off on that, but nothing to shake a finger at yet, really. And this is 100, barely off. It's supposed to be. It doesn't read to the decimal point of this accuracy. This accuracy goes down farther. Well, okay. About continuity, how's the buzzer sound? I can go too fast. It does latch, but yeah, you have to give it a sec. You have to give it just a slight second. So it's slow. Because with a good meter, but that could just be the probes. The probes might not be able to make quick enough contact through the coating because it's got some kind of a silvering coating on it. It's working, so there's a diode on this board, so we'll just test it. So you get 0.6. There you go. Shows a good diode. And if we reversed it, I'm doing this in circuit, so this might fail on me, but yeah, it's showing open. So perfect. So now let's get out my my very precise resistor substitution box that I built from another guy built it online. I just followed his general instructions and built my own. I have a BOM list for this and everything. I just never really posted my BOM list. I have a build process for this and everything. I should make a video on this. Another guy did, but mine's a little different. The way I use different internal parts and different precision resistors and stuff. It's probably a little challenging for this guy because this resistor box has lots of connections in it and stuff. So we rel it out. This should be 1.2, but I don't think it's going to be that precise. Ooh, it brings it the other way a little bit to 0, so this might be closer to 1. No, it doesn't like the substitution box that much. Okay, let's go to the bigger stuff. Let's take off rel mode, and let's go to, say, 10 ohms, and we get 20. So let's rel that out, and now let's go 10. That's pretty close to 10, 10.8. That should be 20, 20.22. That's not so bad. I mean, it's not a precision thing, it's this stupid box, just it's got lots of connections in it. It's probably not, it's not the best thing for that. It should be 30 and we're 30.5. So this should be 130, 230. So we go back to 0, and that should be 9K. Oops, we're in auto range, so we gotta switch back to auto ranging again. Oops, sorry. They're auto ranging and no rel now, and we should be at 9K, and we are. We should go back to 1K. That should be, whoops, 1K, and it's got 1.005, so 5 ohms off. That's not bad. So let's go 10K. Interesting. It's 10K. 100K. It is pretty fast. It wasn't too slow at all. Here's a meg. How quick can it do a meg? Oh, it wasn't too bad. A little off. I don't know how precise this is. It's going to be pretty precise. There's the 10 meg. And it's supposed to do 40 meg, I think it said, right? Yeah, it's supposed to go up to 40 meg. Well, let's give it a try. There's 10. There's 20 meg. It's holding its own. 30 meg. No problems. 40 meg. Still there. Let's go 50. 50 over. So, well, I hope you can see the right down. It's easy for me to see, that is, if you're looking at the meter, you do see that measurement real easily. It's not like not noticeable or something. So a little capacitive substitution box. So if you want to note the precision on this, there, take a screenshot of that, and you know the precision of this box. And then I got a BOM list for that if you want to build one. And we'll go capacitance, and we'll go on microfarads. That's not too far off. 100 nanofarads is really close to 0.1 micro. That should go down. That should be 68 nano. Yeah, that would be right. 68 nano, 56 nano. Yeah. And the last is 4.7. Man, does really well. So let's go into pico. This would be pico. That picks up where this left off. So you leave this knob and you flip this switch to this side, and that puts you over to this knob. So now everything is from this knob, and that should be 33 nano, and that should be 1 nano, and it is. Should be a half nano, or 500 pico. And let's go down to 100 pico. Yeah, there's 150 pico and 100 pico. Oh man, that is great. Now the kicker, can we go lower? So here's all my small scale pico capacitors for doing things like, well, if the crystal offset and crystal oscillations and stuff. So we'll pull out 22 because that's the most common one we use for, like, there we go, we pulled out a 22 picofarad. if this thing reads 22 picofarads, or in this scale it'll be 0.022, that's going to be awfully impressive. Oh, I'm not getting nothing. No. So this one was well within the, this is be 0.27. Yeah, this is 0.27. That's 270 nano. So obviously it can do that scale. No, that would have been so impressive if it could have went down. But I mean, we went down to 100 picofarads, but yeah, getting under 100 picofarads, that's tough to do. And that's so really it goes higher than what it says in here. This should say 2000 in this 200 range. It actually has a higher range than that, is what I'm saying. And it says so in the manual. Let's throw the top of the range at it. This is 2200 micro. So that should be a little bit higher than its maximum range. Let's see how it fusses with that. And it's slow, but it's going. There it goes, 2.5 microfarad, or millifarad, sorry, 2.5 milli. And I'll bet you that's probably pretty close. It says it's 2200. But you know, for this, you know, you're happy. You're very happy. So the will it light the diode in diode test? That's always nice to know, right? Oh yeah, it lit. Yeah, sweet. It lights the. It's a little diode. It's a little LED, but it lights it. So this nice little meter is supposed to do 10 megahertz. So we've got our HP 8640B signal generator. This will start off at I can go a little bit under half of a megahertz, or 500 kilohertz, up to I believe this goes up to 500 megahertz. Yeah. I have the output signal coming from right here, and it's going into the test leads directly. So we should be able to flip on the output, and that's reading 500. Let's tweak it up so it's exactly 500 kilohertz. And this is a little bit out, and so we'll find out how much by just dialing this up until it switches to dead on 5 over here. 500 right there. So it's about 45 hertz off. That's not too bad already. Let's go upscale. Okay, that should be a megahertz. It's still on in a megahertz. Not more than 90 off now. And so we're going to probably stay pretty close. 2 megahertz, 218, 200 and 180 that is. And that's 4 megahertz, there and there. 8 megahertz, 16 megahertz. Now that's over its noted scale. It's only supposed to do 10 megahertz, and it's holding fine. Now this is a fairly strong signal too, but still, it is doing the business. 32 megahertz, it's still going. And 64 megahertz, it's still holding. Oops, there she dropped out. So 64 megahertz on that scale is about it. Whoops, it kicked out just now, so it's not even holding at 64. We'll back it off. Okay, it's happy there. Yeah, it kind of makes sense if it'd be around 60 megahertz, it would doof up. There's 59. So yeah, so even though it says 10 megahertz, it will actually perform fairly decently, well up into almost 60 megahertz. Not bad for a little handheld. And normally I'd be the first person to tell you not to use a smaller sub-Chinese anything kind of cheap multimeter for mains. But I did see the front end of this thing, and it had a lot of, it was decent. You know, I'm comfortable with it. I don't recommend you try this with anything over 60 volts. This thing's rated for 600, but judging by the size of the cables and the size of the components and and the clearance is inside, you know, I would 60 would be the max. 60 volts would be it. And if you want to be really safe, then, you know, stay under 35 volts. But this is going to be mains. I'm going to do duty cycle, and then I'm going to do, well, first I'm going to do hertz, and then do duty cycle. So I'm just going to hold some pressure here. Those are plugged in. If it can't handle it, we'll see it smoke, and I'm wearing glasses, so let's hope. Okay, you ready? This should give us 60 hertz. No, it fried it. I think she might have died. I don't think she liked that at all. It should have been able to do that. It went into some kind of protection mode. I don't think it says you anything. I'm going to read the manual here real quick to see if there's any reason I can't do this. Well, I'm a little rusty on my, what is it, kanji or Chinese? I don't know. It says 3 volts peak to peak, up to 10 megahertz. 3.5 volts peak to peak. I don't know. Then it says something, and then 250 volts something. So I don't know. It's the only manual I got. So this is the hertz and duty cycle. And to this, read the manual stuff, I went ahead and did some correcting. They had some misused grammar, misused words, unnecessary sentence structure completely. It's definitely written by foreigners. But hey, maybe they could look at this and go, oh, we can correct that. But it says to read the manual. Well, I can't. I'd love to, but I can't. Maybe I could find something online. But I also increase these parameters. This actually goes to 200 microfarads, and it even says so in the manual, in that it has a number there for that, I guess. We're on hertz again, and so if it should go that high, it should go up to that voltage, and that time it did. I don't know why last time it didn't. Should be 60 hertz, and if we go duty cycle, it should be 50, which it is. Yeah, the fluke said spot on 60 hertz, so this was off by a little bit on the hertz side. So I'm going to come over to, and we're going to go ahead and check to see if this thing will read mains properly. Now, I don't recommend you do things like this because this is mains. If you don't know what you're doing, you do stuff like this at your own risk. I'm not tutoring you on how to do this. I'm just showing that I can test a meter, and it says 121 volts. Okay, I will check that with the fluke. Yep, the fluke tested 121 volts AC just the same. So yeah, no worries there. So maybe a really short teardown. I don't really gonna go over it in detail because we spent way too much on this mailbag day. But we do want to see a little bit about what in the world's going on inside this thing. If for nothing else, we can say we've looked inside, right? Right? Any ideas how to open it from here? I lose my screw already, like I said not to. And look at that. Fancy spudger I got at the beginning of the video is the very tool you need to get into this thing. Perfect. Nice edge, and seems to want to come off quite nicely. Okay, so a little bit of shielding. Looks like there's a buzzer. Looks like there was a shield. Normally this is where you have like little melted over heat stakes for like a piezo, but there isn't one. They must have a different kind of speaker in there because there's definitely a piezo in here. This is 2013 0827, and then a hold button. There's no hold on this at all, but there's an option for a select and a hold on the back. That's interesting. And that's just for the shielding that's back there to connect to that foil shielding. Okay, let's get into this a little deeper. Okay. Okay, so that's how that pops out, and that pops out. So these are little springy contacts. Well, let's look at this first. There's the zebra strip for connecting to the display, and then there's the buttons, and then there's the dial. The dial is sort of fixed in there. It is a really fine feeling dial. That's neat enough. And then there's the dial select with the different. It looks like they're well coated. Nothing cheap there. Then there's the buzzer, so there's no point in them putting a buzzer on the back shield when they can put that on the surface. There's where the range and the hertz buttons are. And then the chip on board, the cob, a crystal even. I wonder what that chip is. Can you read that chip in the HD? We'll take a look at it off screen. So then that is a serial EEPROM. It's a 2-wire serial EEPROM, and that's what these test leads go down. The test leads are down here for. That's probably how they calibrate this thing and store the necessary calibration offsets for this. This will be just a standard run-of-the-mill cheapo, well, not cheapo, pretty darn good digital multimeter die in there. And then this will have its necessary stored information to correct for anything that this has for drift and fault and stuff, because it's really fairly accurate, you know. And we got, you know, reasonable input protection going on coming in off the positive lead. We have 2, 4, 6, 8, 10 mega ohms, and it's a ladder style, so they didn't just use one resistor, they got multiple resistors, which is a far better performing input, so that you're dividing that against all of these surface mounts as you're coming in off that lead. And then there's a PTC, a positive temperature coefficient. That's some more protection. A couple of diode protections, both of them in parallel. So real reasonable for a handheld. Jeepers criminis. I mean, you're sitting pretty sweet for a handheld, that's for sure. You won't get out of anything off a Harbor Freight, and you won't get anything performance-wise like that out of anything else. So, wow. I kind of wish the coating on here. I mean, it's got a decent coating, but I wish it was a little more sensitive. It seems like it's sort of like a plating. That'd be one thing I would like to improve. But well, let's see what's inside here, because this was pretty sweet too. Oh, that's not good. That might not come out so nice. I'm beating this thing up so bad. Will that come out of there? There, it snapped. Oh! Don't do that. Don't do that. Don't lose them all. They're just barely sitting in there. These are just waferly laying in there nice and gingerly. Okay, well, we can get them back in place. Okay, so that's there, and still it has a nice good click to it, so it's, oh my God, my OCD is just killing me. What's in there? Terrible to have my disability. I tell you, it just gets me into so much trouble sometimes. Oh, I got it. Did I break it? I don't know. I don't care. Ball bearings and springs. Good Lord, no wonder why it felt so good. Look at that. Ball bearings and springs. Those are spring loaded, and a little bit of grease. Holy crap. And then a nice clicky indent. Jeepers criminis, people. Go out of town and build something, why don't you? Jeez. Yeah, that snapped right back in there again. That is okay. That is the best range switch I've ever felt on anything sub quality fluke. I mean, even these flukes sometimes even only have like these little plastic springies in here. This is not ball bearing. That is ball bearing. And those spring contacts, they pop into place real easily. They kind of hold in their little cradles there. So that should just go on like that, and that just holds on like that. And they kind of clip in there so they hold themselves in place. They're off. Okay, well, let's continue with the reassembly. Okay, not too fiddly. Got my 4 screws back in, and this wire is going to have to kind of scoop on the side there, and we got to get our hinge on and our cover on. There, that snapped in correct. So now for a couple of batteries. And then, just come on. Oh yeah, sweet. Now for the more important thing. Does the hold button actually hold? So when we're on AC and it's kind of flopping around as the leads move about, what happens if we hit the hold button? If we short that out? Well, it didn't hold. Let's see. It does hold. You see there? It says hold right there. Oh my goodness sakes. That's sweet. So you do have a hold button, but you'll have to, I don't know, wire up to this button and bring yourself a little flip switch on the side maybe, and or make yourself a little soft something. You have to wire. If you really want a hold button on a pocket multimeter, you have it. I suppose a double tap takes it off. Yeah, and then that takes the hold off. I don't know what to select. I'm gonna stop now before I completely destroy my toy. This is true RMS, and that holds true because when we did this test, we did this AC test. This wouldn't read correct because this is a square wave, this AC, and if you have a non-true RMS meter, you won't get the proper voltage reading. You have to have a true RMS to get that bang on perfect reading, which this did, so it is a true RMS. So if you want it to come up without the auto power off, like if you just don't want it to power off after 15 minutes for some reason because you're doing a long test or something, that is what the secret select button is on the back inside the battery case. That's the hold button, and it does work if you could manage to wire it up to it, and that is the select. But the way you use it, I found out, is you have to short across that connector while you turn it on. And so when you turn it on with that select button pressed in or activated, then you get that deactivates the auto power off. So now if I turn it off, turn it back on, we should have auto power off, APO. So that'd be nice if those two buttons came out. I mean, if you could have a hold button, you could push a hold button here and a select button here to disable your auto power off feature and or your hold button. So what we're working on now is we want to test the quiescent current that this thing has when it goes to sleep, because we know that it's using about 2 milliamps just to do almost all of its range. It's only using 2 milliamps, but when it powers off, how many microamps is it using? Well, I can't measure microamps with this because it browns this guy out on and off, and so you'd never get it to go to sleep. So we make sure it's in the power off mode, and then we bring in Dave Jones's microcurrent. Now the microcurrent is designed to do just this job. It converts, essentially we got the power coming out of the little probes down here. That's actually goes through the batteries, but before it gets through the batteries, it comes over to Dave Jones's microcurrent. I got it currently set on 1 millivolt per microamp. That's the center switch setting right there. It'll do 1 millivolt per milliamp, 1 millivolt per microamp, and 1 millivolt per nanoamp, meaning when this reads a millivolt, whatever range this is on is its amperage. Now the burden voltage, if you could see right there, is 10 ohms. So in 1 millivolt per microamp, there's only 10 ohms of burden voltage, which is a lot less than this meter can do when it's trying to do microamps. So it will do microamps. It just on the verge, it just browns it out. It drops the voltage too much on this guy. So it was resetting. So this will stop that. This will actually let this thing go to sleep now, and then this display will read for every millivolt that this thing is going to read, and it's got it in high res mode too. Every millivolt will be a microamp. Okay, hence this is a really convenient tool for measuring microamps, the microcurrent. And we'll know exactly its quiescent. We'll know about how much current it's using in sleep mode and be able to then calculate how long will it run in sleep mode if you leave it on. But do you have a day? Do you have a week? Do you have a month? How long will those AAAs give you? Okay, it just gave the 5 beeps. That means it's about to go to sleep. So let's see what it does here. After those 5 sharp beep, there it goes. And now we should start getting a reading. Yes, we do. So there we go. It is 1.56 microamps. It's someone shoot me in the head. God damn it. Okay, its power off current is 1.56 microamps. Wow, that's tiny. So that means that when it's normally using 2 milliamps in run mode, it'll last about 2 months. This thing could actually run non-stop without an auto power off for 2 months on 2 AA's, because AA's are about 1,000 milliamp hours to 1,200 milliamp hours, and there's 2 of them in there. So that would be pretty. Oh, this guy just went to sleep too. So that means when this thing's actually on and drawing the 1.5, I can go into high res again. When this is drawing the 1.56 microamps, this thing literally will run in sleep mode for as long as the shelf life of those AAA batteries. That is, the AAA battery's shelf life will expire years before this thing will burn through the power that's in those AAA batteries. So once this is in sleep mode, you don't have to bother with it. It's fine. It will not drain those AAA's. And that's the nice thing, that this doesn't have the button cells in them, because those AAA's are just got that much capacity. It's not going to ever matter. But amazing that, 1.5 microamps to in sleep mode. So you don't even have to bother. It's just like the other meters. You just don't bother. But yeah, turn it off, and then you can close it up. Guess I gotta take off my little cheater amp meter probes. Oh, this just gets better and better. This is oh my gosh, take a look at this. I wasn't going to be a fan of the strap, I just didn't think that'd be no big deal, right? But well, no, catch this out. Something you never get to do with pocket multimeters is, once you have them in any configuration, you don't get to use them on a bench. They're just on the bench. But this has a little tilt mechanism, so you get a little bit of an angle. See, it's not a lot, but because the way that hinges, you get a little bit of an angle. So it's a pretty decent angle there just for some bench stuff. And you can tip it up, and it will kind of set a little bit. But this little handle feeds through. Oh my God, they think of everything, don't they? Nowadays, they just think of everything. It feeds through what was the little cover for the little feed through for the knob. And then if you have a pencil handy, you drop a pencil down in there, or whatever object you want, and now you have a meter that will stand up on your bench. And if you have a clip or something, like say you don't want to bother with the pencil, but a pencil works really good. It stays in there and it holds it up and lets you use it at that level. But if you have a clip or something else a little more fancy, then you can kind of set whatever angle you want. You can have a higher angle or a shallower angle, because you can just have a clip in there. And then you can use your about this angle for using your meter. Doesn't really show good with the lighting, but yeah, I wish it doesn't have a backlight, that's for sure. But now you have a clip or something, you have a pretty reasonable, or a pencil. A pencil works too, and then you can do your probing, and almost like you have a real digital multimeter for $24. Okay, impressive item number 88. Pop, they fling right out, and you can go to work. Do some continuity testing. And I'm off and running. Probe, 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 probe. And you got a tilting bail. And yeah, they tuck in pretty quick. No big fuss with the tuck in still. Closes up good still. And nice and safe, no wires flopping around. And I pop those in, and I'm really used to it now. It's about the fourth time I've done it, and they go in real nice. So there you go. Absolutely, undeniably, the best pocket multimeter I have ever witnessed in my life. This is going to stay close at hand. Now to find that screw. Oh, I did. Wow. Here I thought I'd lost it. Well, thanks for joining my, probably that's technically my first mailbag. I got my stuff from Adafruit, and what else? I got my spudger, which came in handy for this. I'm going to be able to wire up a circuit that I got, and I got extras of those, and I've got the champion of all, the absolute champion of all pocket handheld multimeters. Well, yep. Thanks for joining.